Here in this video, we are solving a problem from the chapter waves. The problem is like this. A wave is in a string having an amplitude of 2 centimeters. So let us take down the data that is available for us. Amplitude is given for you as 2 centimeters. You can convert that into meters as 0.02 meter in SI system. The wave travels in positive x direction. A wave's displacement can be represented as y equal to a sine omega t minus kx or kx minus omega t. Both of them, this minus indicates wave is moving along positive x direction. If he has given it is moving negative x direction, I could have written a plus in the place of minus. So minus is an answer. So wherever there is a plus, this cannot be your answer. And this also cannot be your answer. You can actually rule out the two options, but I'm not explaining the ways of ruling out here. Rather, we are willing to solve the problem along the positive x-axis with a speed of velocity of the wave is given for you. Velocity of wave. We know the formula velocity of the wave equal to n lambda, or we can also express it as omega by k. Hope you know why, from where you got that omega by k. If you want to know, I want to tell you that omega can be expressed as 2 pi into n, where n is frequency. K can be called a phase constant, who is equivalent to 2 pi by lambda. Then omega by k will be 2 pi n by 2 pi by lambda. 2 pi cancels. I'll get n lambda, that is equal to velocity of the wave itself. So velocity of a wave can be expressed as omega by k. That is given to you as 128 meter per second, right? But I don't know the individual values of that omega and k, both of them. I need to find out. And it is noted that 5 complete waves. What happens? What do you mean by 5 complete waves? When there is a wave, one crest and one trough will be there. That wave will have a certain length called wavelength. And there are 5 waves like that. There are 5 wavelengths like that. That means when he says 5 complete waves means there are 5 wavelengths. 5 times of lambda in 4 meters of the length of the string. So 5 wavelengths in 4 meters in SI system. So lambda is equal to 4 by 5 meter. So you got lambda as 4 by 5 meter. Once if you got lambda, you can find out the value of the k using this formula. K is 2 pi by lambda. That is 2 pi by 4 by 5. That is 10 pi by 4. That's the value of the k, phase constant value. You know the value of the k. We know the velocity of the wave. Using this velocity of a wave concept, as you have found the value of the k, now we can find the value of omega. Yes, V equal to omega by k is given to you as 128. Omega by k value is found as 10 pi by 4 is 128. So omega is equal to 128 into 10 pi by 4. That's the value of omega. So if you calculate that value, how much it will be? Omega can be found, right? So what's the value of that omega? 128 into 10, pi is 22 by 7, and then 4 is there, right? So if you try to simplify this, 4 threes are 12, 4 twos are 8, 7 fours are 7 fives are 35, 32, so they won't get cancelled in any way, right? So what is remaining is, so if you calculate, that's value becomes close to 1005. You can also calculate the value of this k. K value is, yeah, K value can be found as, you have found that K value is 10 pi by 4, that is 10, pi is 22 by 7 and by 4 is also there. So you can simplify this further, 2 5s and 2 2s and 2 11s, that is equal to 55 by 7. If you calculate that 55 by 7, that becomes 7.85 approximately. Now, if you observe carefully, you know the value of K, you know the value of omega, you know the general format y equal to a sin kx minus omega t. When you put all these things together, displacement of the particle y is equal to a sin kx. K value is 7.85 into x. Moving along a positive x-axis, therefore a negative sign, minus omega. Omega you found approximately as 1005. T is the right representation for the wave that you have been talking about, right? This answer is of course wrong. These numbers are wrong. That's why that answer cannot be the answer. Rather, this is the answer for the problem. C is the answer for the problem. That's how we have to solve the problem. Thank you for watching.